This is an experimental assignment completed by Group 1 as part of our thermodynamic practical series. Here are the members. In this experiment, we will measure the enthalpy change of a reaction using a coffee cup calorimeter and apply Hess's law to calculate an indirect enthalpy change. Let's gather the equipment. A 3 to 4 stacked paper cups as calorimeter cup, stirrer, thermometer, weighing balance, distilled water, and copper titanium sulfate, both hydrated and anhydrous. The cups are stacked and a lid is provided to minimize heat loss. We begin by measuring exactly 25 milliliters of distilled water using a measuring cylinder. Next, we weigh out 4.06 grams of anhydrous copper 2I sulfate using a digital balance. This salt will be used to observe an exothermic reaction. Similarly, we weigh 6.25 grams of hydrated copper titanium sulfate. This sample will allow us to observe an endothermic process. The experimental setup includes a coffee cup calorimeter placed inside a beaker for added support. A thermometer is inserted through a cardboard lid, which helps to minimize heat loss to the surroundings. A stirrer is used to ensure uniform mixing throughout the experiment, improving accuracy and temperature readings. Now we pour the 25 milliliters of distilled water into a polystyrene coffee cup calorimeter. We begin recording the temperature at 1-minute intervals, while continuously stirring the water to ensure even distribution. After 2 minutes, the steady temperature is recorded as 27 degrees Celsius. We now add the anhydrous copper sulfate to the water in the calorimeter and continue stirring consistently. We monitor the temperature at the 4th and 5th minute marks. The temperature rises to 33 degrees Celsius. This increase confirms an exothermic reaction where heat is released into the solution. Next, we repeat the process with the 6.25 grams of hydrated copper sulfate. The initial water temperature again measures 27 degrees Celsius. After adding the salt and stirring, the temperature decreases to 25 degrees Celsius. This temperature drop confirms an endothermic reaction where heat is absorbed by the dissolving process. All temperature readings for each minute of both trials are documented in a comparative table for analysis. Here are the key notations used in our calculations. Mn represents the mass of the solution, C is the specific heat capacity, dT is the temperature change, and dH denotes the enthalpy change of the system. Using the equation Q upon mc dt, we calculate the energy change for each process. The enthalpy change for dissolving anhydrous copper the iron sulfate is found to be plus 607 joules. For the hydrated copper the iron sulfate, the enthalpy change is 209 joules. To find the enthalpy change for the transformation from anhydrous to hydrated copper sulfate, we apply Hess's law. According to the law, DH3 enters DH1, DH2. Substituting our values, DH3 enters 607, 209, giving us a total enthalpy change of 816 joules. This experiment demonstrates how we can indirectly calculate an enthalpy change using calorimetry and Hess's law. Precise measurements and constant stirring are key to accuracy in these thermal reactions. Anhydrous copper sulfate is classified as harmful if swallowed and can cause serious eye irritation. It is toxic to aquatic life and must be handled with care. Avoid direct contact with skin or eyes and do not inhale any dust. Always wear safety goggles, lab gloves, and a lab coat when handling the substance. Spills should be cleaned immediately using damp paper towels and disposed of according to lab's chemical waste protocol. Hydrated copper sulfate has similar hazards. It is also harmful if ingested and can cause skin and eye irritation. Although less reactive than the anhydrous form, it should still be treated with the same level of caution. Use personal protective equipment at all times and wash your hands thoroughly after handling. Proper understanding of chemical safety helps prevent accidents and ensures a safe laboratory environment for all participants.